first, second, third and fourth module of the Unix system programming. In this video we are discussing about the module 5. There is a two chapters are there guys in the module 5, signals and daemon process. Okay, let's see the what is meant by signal. Okay, signals are nothing but these are the software interrupts, and signals provides a way of handling the synchronous events. These 2 points are important guys. Note these 2 points. Okay, next some signals types and along with the descriptions are given. Just only a few uh, few types are you can practice, like no need to practice all of these. Any 5 or 6 types you can go through them, and moving on to the next prototype of the signal. This is important guys, so just practice this prototype and write over in your answer sheet. Okay, if they ask about the signals, then related to some program is there, no need to practice all of that program. Okay, next second only kill and raise function. Kill and raise function sends the signals to process a group of process, and the raise function allows the process to send the signal to itself. And what it does, kill it see, it pro, you know it it sends the signal to a process or a group of process. Okay, and raise function, what it does, it the function allows the process to send the signals to itself. Okay, this is the prototype of a signal, and raise function is there. Just note down this. Uh, Okay, next in the kill and raise function, there is a 4 parameters are there, 4 values. When the PID is greater than 0, and PID is equal to 0, and PID is less than 0, and when PID is -1. So PID is nothing but a process ID. So the signal is sent to the process whose process ID is PID. This is when PID is greater than 0. It means that this. Okay, so PID is equal to 0 is nothing but the signal is sent to the all process whose process group ID equal to the process and group ID of a sender, and for which the sender has a permission to send the signals. Okay, for that reason we are using the PID equals to 0, and PID is less than 0 and is nothing but the signals is sent to all process whose process group ID equals to the absolute value of a PID, and for which the sender has a permission to send the signals. Okay, so that is the thing. And PID is equals to -1. When the PID process ID equals to -1, it means that the signals is sent to all process on the system for which the sender has the permission to send the signal. Okay, for that reason we are using PID equals to -1. And kill, related to that kill, the some program they given, and raise for that one related example program they given. And moving on to the next third one, alarm and pause function. So alarm function, what it does, the alarm function allows us to set the timer that will expire at the specific time in the future. So if the process is working right now, and when it will expire, we don't know. So this alarm will intimate that the process will expire in on that date, and in this time, like that it will be set the timer. Okay, so see, for set the alarm, we are using the sig alarm function. Okay, sig alarm signals is generated. So when we need to set the timer, no, so in that time sig alarm signal will be generated. Okay, so one exam, this is the prototype. Okay, prototype for this uh, alarm sig alarm is unsigned int alarm unsigned in a second. Okay, next returns the 0 number of seconds until previous set is alarm. For the prototype, under prototype itself it comes guys. And next second one, pause, sig and pause function. In the pause function, what it is, the function, the pause function suspend the calling process. So it suspends the calling process until the signal is cuff. This means that the guys, when the signals is start when the signal while the signals are generated and transmitting in the process, no, in that time if they want to stop somehow, they need to work, no, in that time function suspend the calling process. Okay, it does like that. And Next, the pause function prototype is there. So this is the pause function prototype, and return the -1 with a error, set the entire. Okay, yes. And signal set. Next, coming the part signal set, fourth one. Signal set is nothing but we need to for a signal set we need a data type represent the multiple signals, right? So only for one signals we are generating for one signals, it's not good. For multiple signals set, we can say it as a one way signal set. A single individual signals set together, we can call it as a signal set. And uh, and signal set int signal empty set signal fill set signal add set signal delete set and return. Okay, signal, remember, signal members consist of a set. Okay, this is the one thing. And signal empty set, signal fill set, signal add set, and signal delete set, again repeated for another one. Okay, next, moving on to the signal mask. This is the fifth function, signal mask in a signal. Okay, signal mask, what it does, a process initially inherits the parent signal mask when it is crafted by any pending signals for the parent process are not passed on. Okay, a process may query or set its signal mask via the signal process API that is there. And this is the prototype of the signal. Next, in the signal mask, there is a signal set mask, signal block, and signal unblock is there. And related to that, one given example program they given. And I think this is a sixth one. Next, sixth one is a sig pending function. So sig pending function, the sig pending function returns the set of signals that are blocked from the delivery and currently pending for the calling function. Okay, so it is also similar like a previous one. The signal pending function returns the set of signals and that blocks the from delivery and currently pending. So it just blocks the blocks in the sense somehow another signal, if there is any another signal is working in that time, uh, it does that signal stops that certain amount of time, and again it will start to active like that. To stop that signal, we are using the signal pending function. Okay, this is the prototype for the sorry this is the prototype for the signal pending function. Okay, next, and related example is that next, signal action, seventh one is a signal action function. Okay, signal action function, we can use this signal action function for to allow us to examine or modify the action associated with the particular signals. Okay, and the signal API is replacement for a signal API in the latest Unix POSIX system. In the latest Unix POSIX system, we are using the signal action. So signal action, sig action, the word itself says, guys, sig action, signal action. It takes the overall signals action and it controls wherever they want and what kind of works they have to do. All the signals works will be controlled by this signal action. And signal action prototype. This is the one you go through that prototype. Okay, and next, moving on to the this is some description of for that signal sig action and sigchld and signal and the wait PID function. This is not asked at all, but sigchld signal and the wait PID is also very important. Okay, um, important in the sense to explain the related to sick child and wait PID. Wait PID somewhere asked this question. Okay, wait PID about wait PID API, and there is a in the wait signal child. There is a parent accept the default action of the signal sick child signal, and parent ignores the sick child signal. And third one, process catches the sick child signal. Are three terms are there. And this is also very important, guys. Here, C is set sig set JMP and sig longjmp API. We are already studied about the Setjmp and the longjmp API in the third module. Okay. Similarly, same function also, but here along with the signals, these Setjmp and longjmp are working. Okay. The prototype for this Setjmp and longjmp are this one. See, include Setjmp function header is included. Int Setjmp buffer buffer is environment, and int save mark is there for a Setjmp, and sig longjmp Sigchld buffer env and int value is there, and relate for that set Setjmp and sig longjmp example program they given over here. Okay. And next, moving on to this signal suspend function. Signal suspend function, what it does, the if the signal is sent to a process while it is a blocked, okay, the signal delivered will be a delivered until the signal is unblocked. The signal delivered will be deferred. Deferred in the sense, delivered will be deferred in the sense, taking a difference of time until the signal is unblocked. In that time, signal suspend is come out of that work. That is called suspend. Okay. Signal suspend function prototype, this one, guys. This is the signal suspend prototype. Just note this point. And abort function quite commonly, we to exit the function or to abort that function, we are using this abort function. This is the prototype of the abort. Okay. And abort function program they given, and system function, and similarly system function prototype is also they given. And sleep function. Next, sleep function is nothing but if the one process is working there, so after that certain amount of time, it's has to be stopped, like there's no any work to process. So in that time, that uh, signal passes through that process, and sleep in the sense stop a certain amount of time, it stops the working. So for that reason, signals are using. And this is a prototype. Next, sleep functions are there. Non-sleep is opposite to the sleep function. Next, clock non-sleepers, clock non-sleep, all the things are there. Errors, and these questions are not asked in the question paper. And second chapter, this is the second chapter in the fifth module, daemon process. Okay, daemon process, there is a mainly three questions almost repeatedly asked. One is characteristics, and one is daemon characteristics, and daemon coding rules, and error log system error logs in the daemon process. Okay, daemon characteristics, daemon don't have a controlling terminals, and the daemons are sessions, are group leaders. Anything with a parent process ID of a 0 is usually kernel process started as a part of system bootstrap. It is nothing but a daemon starts when the system starts booting. No, in that time only the daemon will start. And kernel process special and generally exist for a entire life of the system. And mainly you just remember that daemon process runs in the background, and it is nothing. A daemon process definition is nothing but it is a background processing where typically user interact with the uh, interact by sending the notification signals, messages, and handling the traffic events. For that reason, daemon process will be used. Okay. And coding rules for daemons, it is also very important. You just practice these six coding rules. Call the u mask to set the file mode creation mask, and the call the mask and have the parent exit, and call the set set sid to create the new session, and change the current working directory to the directory. Okay. um and unneeded file description should be closed. This is a fifth point. And sixth one is there, you just highlight the key points and explain on your own basis. Okay. Next, example program given for a daemon coding rule, and this is the error logging. This is also asked, this question is also already asked in the question paper, so that's why it is a very important uh, error logging. For the error logging is the thing, but it is a problem, one problem a daemon has a how to handle the error message, like while doing some work in a process. So in the background, if the daemon is working, if they might have any error occurs there, so in that time it is not connected with the users, right? If it is connected, then users will get to know there is a error. So due to the not having the interaction with the user, it is to intimate the errors, it is using the log functions. So in the log files it will write all the errors. Okay, this is the diagram, very important guys. Okay, you just practice the system log. So initially users process starts, so when it they starts, developers will develop directory will be logged, and the unique domain datagram socket will be go through the system log. This is also, and up to a k logs, and the udp port is also connected to the system log. And this all portion are comes under a tcp ip network. So the diagram is a bsd and a system log facility. Bsc stands for Berkeley's software distribution, and the key points are there. Then finally, last topic, signal instance daemons. Signals instance daemons are nothing but a you know the file and record the looking mechanism provides the basis for the one way to ensure the one copy daemon is running. So while running, while daemon is running, it makes sure that only one copying is running, and not allows to more than one, like a lot of files are not able to work over here. Okay, that's why signals instance daemons are the part. And daemons convention, it is a part of syllabus. You just go through it. Daemon convention and client server model. This is all about the fifth module of Unix system programming language. Uh, so hopefully you people are just recalled and revise that topics, whatever the syllabus they mentioned in that syllabus we have discussed, and yeah, we have completed one first module 1, 2, 3, 4, and 5 of Unix system programming. So that's it all about in this video. Thank you for watching.